All right, let's talk about one of the most essential tools in your network security toolkit, the Access Control List, or ACL. I want you to think of it as a digital bouncer for your network, and today we're going to write its rulebook.
So, here's our game plan for this explainer. First, we'll cover what an ACL actually is. That's our digital gatekeeper. Then we'll figure out how to read its rulebook by understanding something called wildcard masks. We'll compare simple rules versus really specific ones, see why placement is absolutely everything, and finally, watch how a smart ACL can stop an attack dead in its tracks.
You know, you wouldn't leave the front door of your house wide open, right? Of course not. So why would you ever do that with your network? An unsecured network is basically an open invitation for all sorts of trouble. And that is exactly the problem ACLs are built to solve. Okay, so let's get right to it. What exactly is an access control list? At its very core, an ACL is just a list of permit or deny rules that a router reads from the top down, one by one. For every single packet of data that tries to pass through, the router looks at this list and acts like a super strict gatekeeper. It's your first, and honestly, your most fundamental line of defense in controlling traffic. And this gatekeeper has a pretty wide-ranging job. You can see it's not just about security. It's also about performance, about efficiency, kind of like a traffic cop for your data. The big takeaway here is the word granularity. ACLs give you this incredibly precise, rule-based control over everything happening on your network. Now, to give our gatekeeper its instructions, we have to speak its language. And in the world of ACLs, that language is written with something called a wildcard mask. I know it sounds a little intimidating, but trust me, it's actually pretty straightforward once you see how it works. Okay, here's the one thing you really need to remember, because it feels completely backwards at first. You're probably used to a subnet mask where a 1-bit means pay attention to this part. Well, with a wildcard mask, it's the total opposite. A 0 means this bit has to match perfectly, and a 1 means I don't care, ignore this bit. It's this flippin' logic that gives ACLs all their power. And hey, want to know a little pro tip to make your life way easier? If you need to figure out the wildcard mask for a subnet, just take 255.255.255.255 and subtract the subnet mask. So for a really common /24 network, the subnet mask is 255.255.255.0. The wildcard mask is just 0.0.0.255. See? Super simple. To make writing these rules even faster, we get two really powerful keywords. If you want to target one single device, just use the word host. And if you want a rule that applies to absolutely everything and everyone, you just use any. These shortcuts are great for keeping your rules clean and easy to read. So now that we know how to write the rules, we have to decide which rulebook our gatekeeper should use. It can either operate with a very simple one or a much more detailed one. And these are what we call standard and extended ACLs. And the difference between them is really all about detail. A standard ACL is simple. It only looks at one thing, where the traffic is coming from. That's it. It's like a bouncer just checking IDs from a certain city. But an extended ACL? Well, that's a full-on detective. It checks the source, the destination, the type of traffic, and even the specific service it's trying to get to. Let's break that down. An extended rule lets you ask these incredibly detailed questions. You can literally write a rule that says, allow TCP traffic from this specific network, only when it's going to this specific web server, and only on port 443 for secure web traffic, and block everything else. That is an amazing amount of control. Now listen up, because creating the right rule is only half the battle. Just as important is where you place that rule. Where your gatekeeper stands is a huge deal, a really big deal. This is the key strategic decision you have to make. Do you filter the traffic right as it tries to get on your network? Or do you wait until it gets all the way to the doorstep of where it's trying to go? And the answer? Well, it depends on which rulebook you're using. And here are the two golden rules. For standard ACLs, you want to place them as close to the destination as you possibly can. Why? Because they're so broad, if you put them too close to the source, you might accidentally block legitimate traffic. But for those hyper-specific extended ACLs, you do the complete opposite. Get them as close to the source as possible. This stops bad traffic right at the front door before it ever gets a chance to chew up your network's resources. Okay, enough with the theory. Let's see how our digital gatekeeper actually performs out in the real world, stopping real network attacks. This is where it gets really powerful. Just a few well-placed ACL rules can shut down some of the most common attacks you'll ever see. One of the most common attacks is something called IP spoofing. This is where an attacker forges their source IP address to make it look like they're a trusted user who's already inside your network. But our gatekeeper is way too smart for that trick. So how do we block this? It's easy. We just tell our gatekeeper, standing at the very edge of our network, one simple rule. Traffic with a private internal source address should never be coming from the public internet. If you see that, you know it's a fake. Drop it immediately. And here's just a perfect example of that precision we were talking about. The ping command can be a useful diagnostic tool, but it's also a security risk. Instead of just a simple on or off switch, an extended ACL lets you get surgical. You can allow your internal users to ping the outside world and get replies back, while at the same time completely blocking anyone on the outside from pinging you. That right there is security with precision. So, an access control list, it's not just some feature. It's a fundamental part of your security posture. It's the gatekeeper that stands guard 24/7. So the real question you have to ask yourself is, have you given your gatekeeper the right set of rules to protect what's important?